Hi, good evening. Welcome to all of our viewers from around the world, especially our friends in Australia, who will be enjoying some of their superstars in critique of climate science and energy policies. Our theme for Friends of Science Society's 19th annual event is Net Zero plus Green Grid equals the Great Regret. And you'll find out why. This evening, we'll be talking with Emeritus Professor Ian Plimer, who has written a number of books. One of his most recent books is right here, Green Murder, a life sentence of net zero with no parole. This is a very comprehensive book that goes through climate science, energy policies, some histories about how things developed the state that they are today. And I highly recommend it for everyone. But before we get to Dr. Plimer's presentation, if I could just give you a bit of background about Friends of Science Society. This is our 19th annual event. For the past 19 years, we have been providing the public with climate science and energy insights by presenting excellent scholars and scientists from around the world, policy commentators as well. And one of the things that we do as a volunteer-run nonprofit is that we ask our members to support us. So we operate on a very small budget. We're not funded by industry, we're not funded by government, and we don't even monetize our YouTube channel. So we'd like to ask you if you would become a member. And by becoming a member, you support us, but you also get a lot of our materials. You get our Friends of Science extracts, which gives you a roundup of political climate science events from around the world. And you also get our CliSci, which is a summary of recent academic and climate science news. So if you could join us, become a member or become a subscriber. And actually in one of our live events, one of our followers on the chat indicated that if the 43,000 subscribers to YouTube donated to us $12, that's just $1 a month, then we'd be sitting pretty as a small little group. So if you can help us out as we go into our 20th year with $20, $200, $200,000, we'll take it. In the meantime, we'll still continue to provide these free events to the public, our reports, our press releases, our videos, and insights on climate and energy policies. Now, we're going to have a live Q&A after the recorded presentation by Dr. Plimer. And if you could just put in the chat, if you'd like to ask a question, please write question and then your question. And our team will collect those and send them to me, and I can then ask Dr. Plimer on your behalf. And sometimes we get lots of questions. If we can't answer them all in one session, maybe we'll be able to put a blog together with the answers that you want. So I wanted to also mention, be sure to set your reminder for next week, same time, except 7 p.m. MDT, for Joanne Nova. She's going to talk about the green grid part of the equation of our theme. Without much further ado, let me please introduce you to Emeritus Professor Dr. Ian Plimer, and climate change. The past is the key to the present. Let's have a look at the presentation.
The past is the key to the present. And if we don't understand the past, there is no way of understanding modern climate change. And the current focus today on carbon dioxide emissions as a driver of climate totally ignore the past. They totally ignore the Earth's orbit, the sun, extraterrestrial radiation, and it totally ignores the oceans and the planetary degassing. But for me, as a scientist, I'm not interested in opinion. I'm interested in fact. And it has never been shown in the scientific literature that human emissions of carbon dioxide drive global warming. We have to prove that those emissions drive global warming before we can accept the hypothesis that humans drive global warming. The past is wonderful. We've had climate change on this planet for 4,567 million years. For 80% of time, it's been warmer and wetter than now. And we've had some big events. The first really big event was the appearance of life. We're not quite sure which Thursday that was, but we know that around about 4,000 million years ago, life appeared. We also know that there was a big event, the first time it rained on planet Earth. And the evidence for that are old gravels and sands and silts in Western Greenland. And this first running water was when we had life on Earth. This atmosphere at that period of time was an oxygen poor atmosphere. It had a lot of ammonia in it. It was one of the planet's first atmospheres. It's had 3 atmospheres. We had the first life on Earth when we had running water. After that, we see that we've had colonies of bacterial life on planet Earth. And these were bacterial colonies 3,430 million years ago. These slides are from Western Australia, where we can see that these bacterial colonies were thriving. They were thriving in an oxygen-poor atmosphere, and this bacterial life was the first life on Earth. The greatest biomass on planet Earth is not whales, it's not trees, it's actually bacteria. 90% of your body cells are bacteria. 15% of your weight is bacteria. You are a creeping colony of critters. Bacteria rule the world, and it's bacteria that interact with the atmosphere and have changed the atmosphere over time. A fairly obscure event is the Pongolian glaciation, which we see in Africa. It's not a global glaciation. It was probably at mid-latitudes, and we don't really understand this. However, this was a period of time when we had an ice age. This ice age was when we had a high carbon dioxide content in the atmosphere, and this ice age was at mid-latitudes. That doesn't gel with the current story we're being told that carbon dioxide drives warming. How can you have an ice age when it's an atmosphere with high carbon dioxide? After that, the planet warmed up. Well, that's what it does after every cold period. And this is when we started to find massive stromatolite reefs in many parts of the world. And these photographs are from Western Australia, where these 2,724 million old stromatolite reefs tell us that we had continents and tell us that we had just the start of a small amount of photosynthesis. This is when we start to add oxygen to the atmosphere. So there is a relationship between life and the atmosphere. And we see that relationship with the second big ice age around 2,500 million years ago. The ice was at the equator, and there were 4 periods when the ice expanded and the ice contracted. And there was a great oxidation event, and there was an extinction, and there was a breakup of a supercontinent. And the most common interpretation of this is that after the ice age, we had meltwaters flowing through the debris left behind. These meltwaters added nutrients to the oceans, and the bacteria thought, wow, I'll have some of these nutrients. And they started to diverge into 2 sorts of bacteria, one which pumped out oxygen and the other which was killed by oxygen. The one that pumped out oxygen had a cell nucleus where all the genetic material was protected. And the one that died in this great oxygenation event was a very primitive bacterium, which still exists on Earth. It's in your stomach and it's in swamps and bogs and places like this. But this very primitive bacteria had no protection from oxidation of its cellular material. So this was the first extinction of life we saw on planet Earth. This was the first time we started to add oxygen to the atmosphere in a big way. And what happened was that our soils changed from green to red. What happened was the oxygen dissolved in the oceans. And what happened is the iron dissolved in the oceans precipitated. as iron ores. And the top left photograph shows some of the big iron ore deposits we have in Australia. We export about 500 million tonnes a year of this. And the bottom right shows the debris left behind by retreating ice. That's called tillite. Much of Canada is covered in till. This is tillite, the rock, and this tells us that we've had retreating ice. And curiously, we see a relationship between the atmospheric oxygen content and mineral deposits. And so in the exploration industry, we use climate change to direct us to areas of interest. We had another big event after a boring billion or so years of ice ages within which we've had ice expanding, the glaciations, and warmer times, the interglacials. And the first of these big ones was the Sturtian glaciation. And this was also at the equator. This was where we had kilometres thick of ice at the equator at sea level. And immediately overlying the debris left behind by retreating ice, which is the bottom left photograph, we had a cap carbonate, and that formed in warm tropical conditions. So we go almost instantaneously from glaciation into an interglacial, into warm tropical conditions. And the right photograph shows dolomite in the Flinders Ranges of South Australia. Now, dolomite is a calcium magnesium carbonate. Dolomites are interlayered with this glacial debris. Dolomite we can make in the laboratory. And the only way you can make dolomite is when you have extremely high carbon dioxide contents in the atmosphere. So that's telling us that this great ice age was when we had high carbon dioxide in the atmosphere. Now that doesn't fit the narrative. The past doesn't agree with what we're being told operates in the present. Just after the Sturtian glaciation, we had sea level rise, and that sea level rise was some 600 meters, nothing much to worry about. And the sea was warm, and in that warm seawater, we suddenly had a thriving of life because we'd added nutrients to the water and we had reef formation. Now, we've had reef formation in planet Earth for the last 3,700 million years. But this was the first time we had reefs with multicellular life and with perhaps coral. And this formed when we had very high carbon dioxide contents of the atmosphere, and it formed immediately after a glaciation event. And we can see from the air, top left, the Arkarula reef, bottom right, and the reef close up. And this reef was found only about 15 years ago. Before that, the science was settled that the oldest complex life we see on Earth was the Ediacaran fauna. But no, with more scientific work, we found that the Ediacaran was not the oldest complex life on Earth. It's now the Arkarula reef. And so science is never settled. Science can never be settled. After the Arkarula reef, we again went into two periods of glaciation. This is called the Maranoan. And in the Maranoan, sea level dropped 600 meters. And the debris left behind by retreating ice, which was at the equator and was at sea level, the debris left behind is covered by dolomite. This dolomite formed in shallow, warm marine conditions. And this dolomite formed when we had up to 100 times as much carbon dioxide in the atmosphere as now. So the popular paradigm that a carbon dioxide-rich atmosphere drives global warming is just not correct. After the Maranoan, we had a sea level rise, obviously. After the Maranoan, sea level rose some 600 meters. The water was warm. It was at the equator. And we had an evolution of bacterial life into multicellular life yet again. And this is called the Ediacaran fauna. We originally thought that this Ediacaran fauna was the first multicellular complex life on Earth. But with more work, we found that the Arkarula reef predates this. So science is never settled. It cannot be settled because we're always collecting new data and always doing new experiments. The Ediacaran fauna survived for quite a time. It was soft-bodied. Some of them had a backbone, and they might be your primitive relatives. But they became extinct. And they became extinct because of competition. And they became extinct because competing life was able to use carbon dioxide dissolved in the seawater to build shells, to build backbones, to build scales. And the Ediacaran became extinct because it got eaten. So just to summarize our glacial events so far, we've had the Pongolian. We don't know much about that. We've had the Huronian, which we find in North America, which we find in Australia, we find in many parts of the world. We find the Neoproterozoic glaciations like the Sturtian and the Maranoan. And by linking geology with astronomy, we can find that every time we get extraordinarily cold events and a glaciation, we have a very bad galactic address. So maybe climate change is not just related to a trace gas in the atmosphere. Maybe there are some other big driving forces. The Ediacaran fauna got eaten out during an explosion of life, which started about 542 million years ago. But this wasn't really an explosion of life. This was an explosion of predation. And the predators had protective scaffolding, and the predators ate the Ediacarans who used to graze on an algal mat on the sea floor. And this period of predation and explosion of life lasted about 25 million years. And all of the phyla that we see on planet Earth appeared at this time. We've lost a few due to mass extinctions, and we've never ever had new phyla form on planet Earth. And of course, the obvious scientific question is why? And the answer is a simple scientific question. We don't know. And it's really important in science to say we don't know. But again, we had the formation of reefs with shell and coral-like organisms. And again, we had a high atmospheric carbon dioxide content, but this was being drawn down into shells, into limestones, and into sediments. And this process of drawing down carbon dioxide has been going on for hundreds of millions of years. After the Cambrian explosion of life, we had a diversification of life. This took place when we had a high carbon dioxide content of the atmosphere, which we were drawing down into limestones and into life. And during this diversification of life, we had a number of hiccups. These were extinctions. And by measuring the number of species throughout the fossil record, we are able to plot our extinctions. Before the appearance of complex multicellular life with scaffolding 542 million years ago, we had a few mass extinctions of bacteria. They're not very clear because to preserve bacteria in a fossil record is not easy. However, we know that we have lost bacterial life with impacting, such as the Acraman impact. We know that about 2,500 million years ago, we lost a lot of eukaryotic life. But after 542 million years ago, when we had complex multicellular life, often with protective scaffolding, we can see that we've had 5 major mass extinctions of life. We've had over 20 minor mass extinctions of life. Yet the catastrophists are trying to tell us we are in the 6th major mass extinction of life on Earth. Not so. Over the last 20% of time, we've had 5 major mass extinctions of life. And these have occurred when a huge asteroid has hit the planet. These have occurred when we've had enormous amounts of lava erupted in continental volcanoes or submarine volcanoes. And each one of these mass extinctions, we've lost a very large proportion of life. Today, we're not losing a large proportion of life. Yes, we're having species become extinct, but that's because we're having an expansion and a diversification of species, and that's because we have the normal species turnover. Just because you have a species on planet Earth doesn't mean it's going to be there forever. Species come and species go, and when they vacate an ecology, that's filled by another critter. In Australia, we hear a lot about our Great Barrier Reef. It's a modern reef, but that reef hasn't been there forever. It comes and goes. Over the last 30,000 years, that reef has appeared 4 times and it disappeared 4 times. That reef likes warm water. That reef grows on old reefs that have been killed when sea level dropped or when storm activity wiped out a reef. Our Great Barrier Reef in Australia is nothing unusual. Inland from our Great Barrier Reef, and this is the photograph on the left, is a much, much older Great Barrier Reef, and we see exactly the same features. We see full reef areas where storms have broken up bits of the reef which have dropped down on the seaward side, and on the landward side we see pummeled up, ground up bits of the reef that storms and currents have moved around. And the reef itself, we see, has been attacked by competing life. On the slide on the right, from Western Australia, we see another Great Barrier Reef. This is taken at a place with a really surprising name called Fossil Downs. And this Great Barrier Reef has all of the features we see in our modern Great Barrier Reef. It has a lot of atolls, it has a lot of small areas of reef that have been attacked by life, and other areas of reef have been growing. On the fore reef side, we see material broken up by tornadoes. On the back reef side, we see bits of pummeled up and broken up reef that have been deposited as sediment. There is nothing special about today's Great Barrier Reef. The only thing it attracts is hyperventilation from those that want to blame every dynamic aspect of planet Earth on modern climate change. This is a well-known diagram showing over the history of the last 500 odd million years that we've had the atmospheric carbon dioxide content decrease. And that decrease is where it's been drawn down into shells and limestones in the sea, and where it's been drawn down into vegetation, such as the periods of the Carboniferous and Permian, where we've had the massive coal forming events. We're actually living in times of low carbon dioxide. We're living in times where the atmospheric carbon dioxide is the lowest it has ever been on the history of the planet. And we can see that there are ice age events there, one at the end of the Ordovician, the Permo-Carboniferous event, the Jurassic Cretaceous event, and of course the modern ice age. And we're in an ice age that started 34 million years ago when South America separated from Antarctica. And with our modern ice age, we have glaciation. This is when the ice expands, and interglaciations when it contracts. We are currently in an interglacial. That diagram is a key diagram. It has been modified a number of times, but that's essentially the sum total of the data showing us that over time, atmospheric carbon dioxide has been sequestered into life. And over time, we've had ice ages and periods when it's warm. And for 80% of time, it's been warmer and wetter than now. And most of the history of the planet shows that sea level has been higher than now. So when I look back in the past, I say, well, folks, what's the worry? Very little carbon dioxide is emitted from terrestrial volcanoes. Most of the natural emissions of carbon dioxide come from submarine volcanoes. And it's no surprise that 97% of emissions of carbon dioxide are natural and only 3% from humans. So we have to prove that 3% of natural emissions of carbon dioxide drive global warming. And then we also have to prove that the 97% of natural emissions don't drive global warming. Best of luck. We can see from shallow water hot springs that there are a huge number of springs emitting carbon dioxide. We have places on the sea floor north of New Zealand where we have pools of liquid carbon dioxide. Oceanic carbon dioxide emissions are the great unknown in climate change. And what happens? They're ignored. As we start to pull apart the Earth's crust, we have basalt lavas and we have a huge degassing of carbon dioxide. A good modern example of this is the pulling apart of the Red Sea, the basalts in Saudi Arabia and Egypt, and the degassing that is taking place on the floor of the Red Sea. But that also happens on the land. And on the land, a good example would be the Columbia River basalt, where thousands of cubic kilometres of lava have been erupted. Together with that have been sulfur gases and carbon dioxide emitted into the atmosphere. The sulfur gases, we know, have a profound effect on life on Earth and perhaps climate. With submarine basalts, we emit gases and we emit heat. Some of these have been measured, and these are telling us that we're pumping huge amounts of gases from deep in the Earth into the oceans. And the main gas is carbon dioxide. It doesn't bubble to the surface. It dissolves in the cold, saline, bottom waters of the oceans. There's some intriguing work done by a Russian on past basalt eruptions and carbon dioxide in the atmosphere. And this suggests that there may well be a relationship between what happens on the ocean floor and changes in the atmospheric carbon dioxide content. The science is not settled. We cannot be dogmatic about carbon dioxide. All over the planet, we are degassing carbon dioxide. Every time a molten rock rises and solidifies, we degas. And much of that gas is carbon dioxide. A lot of it is water vapor, and we have other sulfur gases. This is an area in Northern Australia where we've had 3 periods of degassing every time molten rocks rose. There are some 200 carbonatites worldwide. These photographs show a modern carbonatite lava in East Africa, which has erupted a rock which contains over 40% carbon dioxide in the rock. With these eruptions, we leak huge amounts of carbon dioxide into the atmosphere. It is very hard to calculate what contribution these weird eruptions have made to atmospheric carbon dioxide. Not all volcanoes erupt lava. Many of them just erupt carbon dioxide. And if we're trying to do a sources and sinks calculation as to where the atmospheric carbon dioxide comes from and goes to, we cannot ignore these type of volcanoes. Every time we rip apart the Earth with an earthquake, we leak out warm fluids. We also leak out a lot of carbon dioxide. We also leak out methane. So not all carbon dioxide derives from human activity. There are many areas where we know we're leaking out carbon dioxide, but we haven't got enough data to be able to calculate exactly how much is being emitted. Every time we pull apart the planet, we leak out carbon dioxide from deep in the Earth. Every time we push together parts of the planet to form mountain ranges, we cook up rocks and we leak out carbon dioxide, and quite often we have hot springs with calcium carbonate or hot springs with carbon dioxide bubbling through them. That is another source of atmospheric carbon dioxide. Again, our calculations are very fuzzy on how much carbon dioxide is released into the atmosphere. We can see in modern mountains that we have hot springs and degassing. But where these mountain chains have been deeply eroded, we see that the rocks have been bent double. We see that they were molten. Carbon dioxide and water fluxed those melts. And when those melts solidified, those gases were released. So we have a good idea what happens deep under mountain ranges, and it's a process of degassing. Again, those degassing processes are not seriously considered as part of the sources and sinks of atmospheric carbon dioxide. If we release carbon dioxide into the atmosphere, it doesn't stay there very long. It gets sequestered into the oceans, into plants, into soils, and into rocks. And our oceans do not become acid because of the very reason that we're sequestering carbon dioxide into the oceans. That combines with calcium that is carried into the oceans with rivers and streams, and that gives us calcium carbonate, which we sequester and lock away in sediments, life, coral reefs, etc. So carbon has a cycle, And we are constantly releasing carbon dioxide from the planet, and we're constantly sequestering it into rocks. We see that in the past. There's no reason why that shouldn't take place in the present. Not only do we have a carbon cycle, we have other cycles. There are cycles of climate based on pulling apart and stitching back the continents. There are cycles of climate depending upon whether we have a good or bad galactic address. There are cycles of climate depending on our Earth's orbit. There are cycles of climate depending upon the amount of energy the sun is pumping out. There are cycles of climate that respond to the sun's energy, and these are the 60-year cycles in the oceans. And these are so well known that ancient Chinese calendars were based on 60-year cycles. And there are cycles of climate based on whether we're pushing warm water into the Arctic based on lunar cycles. So climate in the past has never been driven by atmospheric carbon dioxide. If it were, then you couldn't have had 6 of the 6 great ice ages start when the atmospheric carbon dioxide content of the atmosphere was higher than now. There are other major planetary forces driving climate. It is not a trace gas. Collecting of ice cores from drilling in the Arctic and Antarctic show that we've had interglacials which are short and sharp, and long periods of glaciation where there are massive changes in temperature. Today's interglacial on the far right is not as long or as intense as previous interglacials. We are not living in a period of time where climate is changing quickly. We are not living in a period of time where climate change is unprecedented. If we look at the past, we get a perspective of our dynamic Earth, and just because something changes in your lifetime doesn't mean that you've changed it. If we go back in time and look at organisms that floated, they have a chemical fingerprint. And that fingerprint tells us that we've had numerous warmings and coolings. That chemical fingerprint tells us that the warmings and coolings we're experiencing since humans have been on Earth are not unprecedented. And these warmings and coolings in the past could not possibly be due to humans. And so the whole scare campaign that we're living in unprecedented times and that humans are driving climate change is not commensurate with what the past tells us. If we look at archaeology and history, we can see from a very large diversity of data that we've had cycles of warming and cooling. And if we are to argue that the modern warming is due to human activity, then what about the medieval warming, or the Roman warming, or the Minoan warming, or the Holocene warming, and on we go? There is no evidence to show that today's modern warming is unprecedented, is related to anything that humans have done. If we want to understand the present, we must look at the past. How do we know it was warmer or cooler in the past? There are many methods we can use. And one of them is to use chemical fingerprints left in sediments, left in tree rings. And this shows us that when it was very cold in the Little Ice Age, that we had bombardment by cosmic radiation. And now we're out of the Little Ice Age, we're having less bombardment. So we can actually calculate very accurately what past temperatures were, and the further we go back in time, the less accurate these measurements are. And scientists argue about measurement. How was it done? Who did it? Where was it done? What were the instruments used? What's the order of accuracy? So if you measure past carbon dioxide contents using an isotopic technique, the black line, you get a huge amount of variation. If you measure past carbon dioxide content based on a bucket chemistry method that was used in the 19th century and up to the mid-20th century, again, we show this huge variation. But if you use the modern measurement technique of an infrared spectroscopy measurement in the green line, we see that carbon dioxide content just keeps increasing and increasing and increasing smoothly. And looking at that as a scientist, you have to say, there is a problem with measurement. We have to be skeptical. There have been scare campaigns pointing out that if we double the carbon dioxide content in the atmosphere or quadruple it, then we're all going to fry and die. For a long time, we've known the Beer-Lambert law, and this is showing us a relationship between carbon dioxide content in the atmosphere and forcing, which is in fact a measurement of temperature. So the first 100 parts per million of carbon dioxide in the atmosphere have a profound effect. After that, it's very little. If we doubled the atmospheric carbon dioxide content, it wouldn't have much change on temperature. So why get into a lather about a slight increase of atmospheric carbon dioxide? Sea level has always changed, and in the geological record, our changes have been up to 600 metres. In the last interglacial, sea level was 7 metres higher than now. In the peak of our current interglacial, sea level was 2 metres higher than now. And there are many reasons for sea level changing. We have higher sea levels close to mountain ranges. We have sea level rising and falling depending upon how much new lava we put into the oceans. Sea level does not only change due to tying up of water in polar ice sheets, it changes for many reasons. But we hear this story that sea level is rising and our Pacific atoll nations are going to be inundated. Well, is that really the case? We have a long record of satellite measurements of Pacific Ocean atolls. And what we don't see is inundation over the last 40 years. What we do see is they're increasing in size. That's contrary to the popular scare story we're being told. But we've known this about Pacific Ocean atolls for a very long period of time. In 1833, Charles Lyell suggested that Pacific volcanoes were sinking and atolls kept growing on top of them. That idea was checked by Charles Darwin, and these diagrams from his 1842 book show that we've known since Darwin's time that Pacific Ocean atolls increase in area if sea level rises or if the volcano underneath sinks. So what we're being told about the Pacific Island nations is just not true. It's never been true. By combining a measurement of sea level changes with temperature derived from chemical fingerprints in Greenland ice, we can show in green that temperature has risen and fallen at very rapid rates, far more rapid than today. And we can see that there's been a sea level rise far greater than anything we see at present. And we can see that since Egyptian times, we've certainly had rises and falls in temperature. That's recorded in archaeology, it's recorded in history, and it's recorded in temperature proxies. So I'm sorry, folks, you are living in really boring times. We are not getting rapid sea level changes. We are not getting rapid temperature changes. That's what the data from the past shows us. If we are measuring sea level rise, we also have to measure land level rise and fall. And a good example of this is Scandinavia. Scandinavia was covered with 5 kilometres of ice during the last glaciation. That ice has disappeared during the current interglacial, and in the last 14,000 years, Scandinavia has risen up to 340 metres. So if you're going to talk about sea level rise, you also have to talk about land level rise and land level fall. Otherwise, it is meaningless. At the Great Barrier Reef in Queensland, we can see that there has either been a land level rise or a sea level fall. These oyster beds have been carbon dated, and that date is the date of the Holocene maximum, when globally we had a higher sea level, and when globally we were in the peak of our current interglacial. So the Great Barrier Reef shows us that in fact we have had, since the Holocene maximum, a sea level fall. And when we look at the micro atolls, we can see that these are above the low tide mark. These micro atolls have died, and they've died because we've had a relative sea level fall over the last 4,000 years. We are told that human emissions of carbon dioxide drive warming, but the past tells us a different story. When it snows, that snow captures a little bit of air. When that's compressed in polar ice sheets, the air remains as bubbles. So we can extract that air from ice cores and measure what the past carbon dioxide content of the atmosphere was. And we can measure from chemical fingerprints what the past temperatures were. And we find that in the past, when we've had natural warming, some 650 to 1600 years later, the carbon dioxide content of the atmosphere increases. So it's not that carbon dioxide is driving a temperature rise, it's the exact opposite. A temperature rise then drives a carbon dioxide increase. So what we're being told is exactly the opposite of what we measure and what we know from basic chemistry. Are we living in times where climate change is unprecedented and where the climate change has been driven by humans? Well, not so. When we look back in the past, we can see that every time it's been warm, we've had great empires appear. We are in one of those warm periods. It is no different from anything in the past. So sorry, folks, sorry to disappoint you. You're not special and you're not living in unusual times. Since 1850, we've had 3 periods of warming and 2 of cooling. They've been very, very slight, giving us a total warming of about 0.7 degrees Celsius. During that time, the human emissions of carbon dioxide in the green line have been increasing. Yet during this period of increasing carbon dioxide emissions, we've actually seen a decrease in temperature. So the story we're being told at present is not in accord with the evidence. We live on a dynamic, evolving planet. Everything is changing. And we have the oceans, the atmosphere, the rocks and life are all interacting. Just because something like a landscape or sea level changes in your lifetime doesn't mean you are driving it. We're not living in unusual times. For most of time, it's been warmer and wetter than now. And during those periods when it's been cooler, in these 6 major ice ages, we've had a higher atmospheric carbon dioxide content than now. This high atmospheric carbon dioxide content we have been sequestering into life and into sediments. And in fact, carbon dioxide is plant food. It is not a pollutant. If we did not have carbon dioxide in the atmosphere, we would have no plants. And with no plants, we have no animals. Carbon dioxide is the food of life. And to demonize carbon dioxide is easy because it's pumped out by industry, it's pumped out by wealthy countries, and we can't see it, we can't taste it, we can't smell it. So the past tells us, folks, that you live in very, very boring times on a dynamic planet, and there's nothing unusual going on. Any measurements made in science are dependent upon the order of accuracy of the measurements, any errors that we might have made, data that we might have rejected or accepted, where we made the measurements, who made them, when they were made, and how this data was statistically treated and reduced into something that is intelligible. The validated data from the past is not in accord with what we're being told about modern and future climate changes. And in fact, the battle we have in science today is a battle between measurement and models. And we can show that models are certainly not in accord with measurement. This well-known diagram shows more than 40 years of measurement compared with models that are predicting temperature changes. They do not agree. The red line from the models does not agree with the blue and the green from different measurement methods. If you have a choice, what are you going to choose? A model making a prediction from the future, or measurements showing what has happened in the past? Models of predicted temperature change are not in accord with the data. Here are 4 models based on increasing carbon dioxide in the atmosphere and the suggested resultant hotspot high in the atmosphere above the equator. The models do not agree with the data. The models suggesting that we have a hotspot high in the atmosphere above the equator have not been validated by measurements. And these measurements were from millions of radiosonde balloons. That global warming signature is not observed in reality. We must reject the models. A model published earlier this year is predicting annual precipitation rates. In the past, we can see there's been variation, and all of a sudden, we've had, about 10 years ago, an increase in precipitation, according to the model. That's not happened. This model is unrelated to reality, and that was the case at the time it was published early this year. That model must be rejected. We live on a dynamic, ever-changing planet, and anything we measure today is within long-term variability. And we can understand the present by looking at the past. Nothing we are experiencing today is unusual. Yet there are models that are constructed some 40 years ago to predict what's going to happen with temperature, to predict what's going to happen with hotspots above the equator or with rainfall. None of those are in accord with the measured evidence. However, energy policy in wealthy Western countries is based on incomplete information, on models, and on political and scientific activism. It has never been shown that human emissions of carbon dioxide drive global warming. If we follow the path and try to claim that we are having unprecedented changes on planet Earth due to human emissions, we will pay for this dearly. Thank you.
Well, that was an excellent presentation. Thank you so much, Dr. Plimer. I just want to say that to summarize what you presented, I guess we could just simply say there's no reason for net zero or carbon taxes or trying to reach Paris targets. So joining us now live from Australia is Dr. Plimer himself. Good evening, good morning to you, and welcome. Thank you for joining us.
Thank you. Good day.
We already have a question coming in here. This is from Jim. He says, you show a graph about 30 minutes into the video, the effect of increasing CO2 on temperature in terms of watts per square meter. How much of a temperature rise does this equate to from pre-industrial times to present, and from doubling CO2 from present levels in terms of degrees Celsius?
Well, thank you for your question, Jim. The conversion of watts per square meter to temperature gives us, in the order of the total rise, about 0.7 degrees Celsius, and in terms of doubling the atmospheric CO2, about 0.2 degrees Celsius. Now, if I stand up or move sideways, then I will achieve a temperature change of 0.2 degrees Celsius. The bottom line is there's nothing to worry about.
Okay, very good. Now, we do have some more questions coming in from the team, but I wanted to just mention on your book here, you're saying that green policies destroy economies, freedom, and sovereignty, and net zero means eye-watering debt, no employment, no travel, no reliable food, and blissful socialist happiness with no possessions. Would you like to elaborate a bit on that?
Well, I think those comments are very gentle. In private, I'd say something a little bit firmer. But we've only got to look at what happened in the UK, where people now have a choice between having a hot meal, a hot shower, or heating a room. We've now got in the UK a very large number of people who are in energy poverty. In 2021, we had 31 UK retailers of electricity ceased trading because they went broke, because people couldn't pay the bills. In Germany, which is a G20 country, one of the biggest economies in the world, we now have people in Germany who have been disconnected from the grid because they cannot pay their bills. These people are now going foraging in the forests for wood, for heating, and for cooking. That's an appalling situation. We have a situation in Texas, which I describe in the book, where more than 200 people died when there was a big wind outage over Texas. It was very cold. The wind turbines froze and there wasn't electricity to start them. So we've already seen the economic and health benefits of trending towards net zero. If you take this even further, then if we had a situation with no diesel, then in most countries you couldn't plough, you couldn't seed, you couldn't weed, you couldn't harvest, you couldn't process, and you couldn't transport food from rural areas into cities. There is a real danger of food security because of our energy policy. In terms of the loss of freedoms, it is mandated in some parts of the world that you must take electricity from sunbeams or sea breezes. You do not get a choice. I've beaten that mandate here. I have a 13 kVA generator tied into gas lines. When we have brownouts, which are very common in South Australia, and when we have a lack of electricity with blackouts, it automatically comes on. That is a huge investment I've had to personally make. Otherwise, I would have lost my freedom to energy off the grid. So I see the West is putting itself into a very difficult situation. And I write about this in the book, which came out in December 2021, but I write about the dangers of Europe being dependent upon Mr. Putin's gas, and never a truer word. This has now caused chaos in Germany, where the Greens are now saying, well, we have to view nuclear power, which they've hated for generations, we have to view this as net zero, and we will deem that coal-fired power stations are now environmentally friendly. In the UK, they have a Drax power station that converted from coal to wood because the EU deemed that wood is an environmentally friendly energy source. As a result, there are 300 million tonnes of forests that timber that is harvested and goes by ship to the UK to burn for electricity. That's not environmentalism.
It's crazy, crazy. We have a question here from, we have a question here from Greg. Do you have a view on when our current interglacial period is likely to end?
I wish I knew, but it started to end about 4,000 years ago, and we've been cooling. And measurement is an interesting feature of science. If we looked at temperature over the last 38 years, then the temperature then, 38 years ago, is the same as now. If we look at temperature since 1850, it's been warming. If we look at temperature since the medieval warming, it's been cooling. But if we look at temperature since the middle of our interglacial, it's been cooling since about 4,000 years ago. Now, we know we can have very, very rapid temperature changes. We went from the medieval warming to the Little Ice Age in 23 years. So that type of change we may well have when we end this interglacial. In Canada, that's going to put huge stress on you. In Canada, your wheat harvests will go down. The growing of grain will probably shift about 200 kilometres south. It's going to create a lot of problems. I don't know the date. I don't know the time, but we are overdue for the next inevitable glaciation, and no amount of legislation can change that.
Wow. We have a question from Walter. Are you familiar with retired geophysicist Dr. Peter Langdon Ward's work on volcanic drivers of climate change?
Walter, I am. I'm a scientist. I'm interested in all those things which are unusual, and there are some unusual events such as the El Nino La Nina cycle. The El Nino La Nina cycle may well be related to the heating of ocean waters from deep down. I'm very much aware of Peter Langdon Ward's work dealing with volcanicity and how some volcanicity may well be driven by the moon, by planetary alignments, by solar forces. And I find that intriguing. The evidence is very scant. However, it cannot be dismissed just because we don't have strong evidence. There was very weak evidence for continental drift in 1915. We now have very strong evidence. But I find it an absolutely intriguing idea that the Earth is degassing, the Earth is losing heat. 71% of the surface of the Earth are the oceans, and into the oceans we put heat. That heat is transferred by ocean currents, and in fact, a lot of climate change is related to the shifting of heat from one part of the ocean to the other. So I'm intrigued by this work. I look forward to reading more of it, and I hope I live long enough to see that we can understand volcanoes much better.
Yes, we have a couple of items on our blog from Professor Wis Yim, who's done a lot of work on subliminal volcanic activity and related heating in various streams. We have a question.
Yes, I know Wis Yim. I've visited him in Hong Kong. He's visited me here. Again, intriguing, where he has major volcanic eruptions that are submarine, that affect global weather. And he's published a lot of these in London, and his work I also watch with interest.
We have one from Fillerator, as nickname. We're spending billions on this CO2 reduction lark. Where should we be spending money?
Well, if you'd asked me that question 2 years ago, I would have said, well, maybe we should be spending this on bringing a lot of third world people out of poverty with reticulated coal-fired electricity. I would change that now and say that, yes, we should be spending a lot of money on helping the third world, because once people are wealthy, they have fewer children. And the best way to slow down population growth is to have fewer children. I would argue now that maybe we should be spending a little bit more of our national budgets on defence. The world has changed significantly. But it is a lark. It's an appalling waste of money. It is something that we can do because in today's world, we in the West are extraordinarily wealthy, far wealthier than my grandparents or great-grandparents. We can afford to fritter away money and it doesn't hurt us. And that's what's happening. It's another South Sea bubble. It's another Dutch tulip mania craze.
Yes, tulipomania. Ron has a question. Taking into account the solar and ocean cycles you mentioned, what do you see climate doing over the next 10, 50, 100 years?
Changing. That's it. Changing.
No crystal ball.
I'm not going to do what our climate activists do and present a model telling us that we're going to fry or die or cool down, which I think is going to happen. I'm not going to present a model on this. All we know is from the history of time is climate has always changed. And it doesn't matter whether we've had a democratic government, a Western government, a despotic government, or a king or emperor or ruler. No one has been able to change climate.
Okay. The IPCC computer models have been shown to be less than accurate. Is anyone working on models that incorporate solar and ocean cycles properly?
Yes, I've seen a couple of them. One is a Russian model that excludes carbon dioxide as a driving force. And surprise, surprise, there is a very, very close relationship between what has been modelled and what has been measured. Um, I'm just trying to recall on my hard disk, which is very slow because I'm getting a little bit old, but I do recall talking to someone last week about their modelling, and they also were able to be much more accurate when they took out many of the assumptions that the IPCC made, and these were the assumption that carbon dioxide is the driving force.
Okay. Andras is asking, hydrogen is the new scam. And he's saying they want to store hydrogen underground. As hydrogen even penetrates steel, how could it remain under porous rock? Could you comment on this?
When we take a spectroscopic picture of planet Earth from space, we see a big halo of hydrogen around our planet. Our planet is losing hydrogen. It's losing it from the core, the mantle, and the crust. And hydrogen diffuses through solid rock, metals, and all sorts of things. Now, we don't mine hydrogen. There's only one place where there's hydrogen that's stored in rocks that we might be able to use, and that's in Mali. A little bit of hydrogen is in gas, in petroleum fields, but in effect, we have to make hydrogen by electrocuting water, using 9 litres of water to produce 1 kilogram of hydrogen. The country that I live in is a desert country. The state of South Australia is a desert. God knows why it was settled by free settlers, but that's another story. So, to make hydrogen requires a huge amount of energy, and it's not a very efficient process. And then to store hydrogen, we need to compress it to 700 times atmospheric pressure, and we need to cool it to minus 253. That is a bomb waiting to go off because hydrogen diffuses through steel. It makes the steel brittle, and you can lose up to 1% of the stored hydrogen per day with the very small hydrogen atom going through solid steel. These ideas were tried in the 1920s and they failed because they were uneconomic and dangerous. Now we have these brilliant schemes where subsidized solar and subsidized wind is going to be used to make hydrogen. And of course, that will be subsidized. And so the only difference between now and the 1920s is that in the 1920s, real market conditions existed, and now all the fads and fashions and frauds and fools are gathering around together to have a subsidized hydrogen scheme. We'll totally have to change our whole energy system. Every internal combustion engine will have to be changed. The whole system of reticulated electricity will have to be changed. It is a dream, and the dream is such that I can make hydrogen and I can skin you alive and I can empty your wallet.
Wow, that's a rather stunning condemnation. I wanted to ask you a personal question, my question. What do you think about what's happening with our children and youth and the whole climate fear-mongering? And if you have any ideas of how we can address that and help them to come back to reality, I guess.
Well, this is a very sad situation in the Western world. We've had 40 years of dumbing down of the education system. And now we have our children exposed to propaganda because these children are not taught the basics. Many of them cannot write, that many of them cannot have cursive writing. Many can't do a mental calculation. Very few have committed a large body of information to memory. So we have our children being exploited by those who are pushing an ideology. And that ideology is evil. That ideology is going to permanently cripple our children intellectually and in debt. And I see this as a form of child pornography, where we are actually using our children as weapons for the future world, where no one is allowed to think, no one is allowed to have an opinion, and where we all must follow the narrative. And I think we really do need to address this as the most serious consequence of our global warming policies. Our children are being affected by climate perverts. I can't be blunter.
Well, Australians always shoot from the hip, and we thank you for that. I also wanted to ask you, I understand that you're a signatory to the Clintel World Climate Declaration. Can you tell us a bit about Clintel? I understand they've just gone over 1,000 signatory scientists and scholars who say there's no climate emergency and natural factors are more influential than human emissions.
Clintel is one of a number of groups which have that view. There is the Global Warming Policy Foundation in London, and they put out their net zero blog. They put out their Global Warming Policy Foundation, and in that group are many, many scientists. Same with Clintel, which is more European based. There was a petition that came out of the US, I think about 15 years ago. There were 30,000 signatories to that petition. And in my country, where our exploration and mining industry actually keeps the country afloat, you would be very hard pushed to find a geologist who would agree that human emissions drive global warming. When you exclude major areas of knowledge to promote your theory, then that is fraud. And this is what's happening with the climate activists. They are ignoring the past. They are ignoring my science. And if you do that, then you come up with a conclusion incommensurate with the data. That's what's happening. That's what Clintel's fighting. Clintel is a very eminent group of scientists, and they are being listened to. The Global Warming Policy Foundation was totally ignored by British governments of both colours until very recently, when the electricity prices started to skyrocket. And then a number of Tory backbenchers consulted the Global Warming Policy Foundation saying, well, is this really the case? And in my activities with them, I have given talks at the House of Commons and the House of Lords on climate change. And there is a kernel of people out there in politics who actually are quite sceptical. And so these groups, such as Friends of Science, such as Clintel, are really important, because when the rubber hits the road, you're going to be the most important groups around.
Well, thanks for that little push there. We did have Dr. Benny Pizer from the Global Warming Policy speak to us in about 2013, and you also spoke to us. I think it was in 2007, something like that. So we're very happy that you came back again for another presentation.
Yeah.
I have a couple more
joined
questions.
Benny. I joined Benny in a talk last week in Sydney. We were both together on the stage. He had a 1 week visit to Australia, which I'm sure would have exhausted him.
Wonderful. So Roger and Tom are asking, why does the IPCC not employ Earth scientists to advise about the real history of CO2 and temperature?
The brief for the IPCC is to show that human emissions of carbon dioxide drive global warming. It is not their brief to understand how climate works. So they are working within their brief. That brief was set by activists, and the IPCC attracts activists and activist scientists who are basically unemployable unless they're frightening people witless, go to the IPCC like bees to honey. So I'm not surprised that they don't employ a scientist. No one wants to hear something that upsets their dogma. So the IPCC is fulfilling exactly what the UN wanted them to do. And that is to try to scare people witless and show that human emissions of carbon dioxide drive global warming. Well, they have failed.
Yeah, well, their fundamental mandate as written is to explore human-caused climate change, not all causes, right? Yes.
That's right. That's right.
We have a question from Butch saying, what can we do in Canada to educate our Prime Minister about climate change? I think nothing.
Vote him out.
Yeah, I don't know that would educate him, though. And Trevor is asking, ask him about using ammonia as fuel.
Ammonia needs to be broken down, but ammonia and natural gas are possible sources for making hydrogen. Again, it's expensive. We use a lot of ammonia, and that ammonia is used to manufacture fertilizers. We use a lot of ammonia, and that's used to manufacture ANFO, which is ammonium nitrate, an explosive used all over the world. So ammonia can be used, but again, you have to manufacture ammonia before you can break it down and use it for a fuel source. And rather like hydrogen, it doesn't occur naturally.
Okay. I have a question from Bill. Do you see similarities between the dysfunctional science theme that CO2 is a primary driver since 1850 and similar problems across almost all areas of science?
Unfortunately, I do. I think science now is so dependent upon government policies and research monies from government organisations that it follows the money. For many years, I sat on the Australian Research Council, and we had a directive from the minister. We must fund any research in our war against cancer. So if you had a research project on ingrown toenails and in some way you could relate that to cancer, you got funded. Exactly the same thing is happening now with climate. If you can show that sneezing on the left side of your face is related to climate change, you will get research funding. Now, I've also sat on the German Research Foundation and the Swedish Research Foundation, and exactly the same happened there. In the Western world, governments supply just enough money to keep research ticking over. They are very much aware that it's a political issue and they must fund research, but they try to fund it to the absolute minimum. This is why there's such savage competition for funds. And at present, it's the climate crowd that gets the funds for scientific research. And a government say, well, we've provided this money, right, no problems, we've done our job. So I think the whole scientific system has been corrupted. There was a time in the 19th century when we had gentlemen scientists who funded their own research. There was a time in the 20th century where a lot of research, a great proportion of the research was funded by industry, but we were warned by President Eisenhower when he left office about government institutions controlling scientific research. And scientists now are providing the answers that governments want. And I would also argue from my 40 or 50 years or so experience in universities that most scientific research are scientists paid by the public to pursue their hobby.
Well, that's pretty direct and quite enlightening. I think that we've taken up quite a bit of your time so far, and I really appreciate you coming on to do the live Q&A, and we'd love to have you back sometime. So I'm just going to say thank you to you, Dr. Plimer, and to offer you all our best, and we hope that people will tune in next week for your colleague Joanne Nova, also an Australian, who's going to enlighten us more about the problems that you describe here as well, about green policies and the green grid. So I'd like to thank you very much for doing the presentation and for coming on our show and making our 19th annual event a wonderful experience for everyone, an educational experience. So thank you, sir.
And thank you, friends of science.
Thank you. Okay, so that was wonderful. I'm very happy that we were able to bring you this presentation this evening, and I hope that people will pick up this book and that you will learn the many things that Dr. Plimer has included in the book, and his even bits and pieces of his own personal history, which also helps set some context. I'd like to once again thank our sponsors for our 19th annual event. I'd like to thank Ken Gregory, W. Brett Wilson, and Prairie Merchant. You offer us a way to bring these events to the public free of charge and to help educate the people who day by day are inundated with media commentary about the climate catastrophe. And as we've seen tonight, we're not in an unprecedented time of climate change. And if you read this book, we are experiencing flooding in Canada right now, in serious flooding, especially across Manitoba. But this is cyclical. Flooding is cyclical and seasonal. And I wish that journalists would actually read this book and learn more about these cyclical natural factors. I'd like to also thank Jay, our event producer, for putting the evening together, and Mike Visser, our technical producer director of the show and of the director's chair. I'd like to thank our board. Volunteer board works very hard. And to thank our loyal supporters and followers. And I hope everyone will tune in next week on Monday night at 7 Mountain Daylight Time, when we're going to have Joanne Nova, also an Australian, as I mentioned, and she's going to talk with us. I'm just going to read a bit from the blog post here: how to destroy a perfectly good electricity grid in 1 million expensive steps. Australia, the crash test dummy of renewable energy. So she's saying, despite having more coal and uranium per person than almost anywhere on Earth, Australia still has managed to make some of the most expensive electricity on the planet, mostly thanks to a pagan quest to control the weather. Find out what it takes to achieve statewide blackouts and tripling of wholesale electricity prices in just 5 years. Laugh till you cry at the folly of a nation that controls just 1.5% of human emissions, yet is trying to change the global weather by sacrificing a commodity which also happens to be its largest export earner. Does that sound familiar to you Canadians? Yeah, kind of. Anyway, Joanne will bring us that information next week. That's going to be May the 9th at 7 p.m. Mountain Daylight Time. So, as I mentioned before, we'd love to have you join Friends of Science. You can go to our main website, friendsofscience.org, and click on the join or donate button. If you can donate, that would be very helpful. We're going into our 20th year of operation, and it does cost us money to produce our videos, and it does cost us money to keep our website going and all of our communications, our press releases, and our reports. So if you can join us, donate, send an e-transfer to contact@friendsofscience.org. That might be the easiest thing to do. That would be very helpful. And if you're not in that position right now, just please share our stuff. And you know what? If you don't agree with us, that's fine. Our position is that we advocate for open civil debate. And we think that climate diversity is our strength. So on that note, I'd like to thank everyone for joining us this evening. I hope you all have a good evening in the western part of the world, and over in Australia, I hope you have a good day, eh? So thanks very much, and for Friends of Science Society, I'm Michelle Sterling. Good night.